everyone, thank you for tuning in. Today I'm going to focus on frequent asked question and topic is trees. And now we are going to analyze what is a valid binary search tree. And let's look up the question. Given a binary tree, determine if it is a valid binary tree. And BST, assume a BST is defined as follows. The left subtree of a route contains only nodes with a key less than the node's keys. So 1 smaller than 2. The right subtree of a route can only contain with the key greater than the node's tree, so 3 greater than the 2. Both left and right subtree must also be binary search tree. So if they have a child, also exactly the same. So in this case, this is true. Look up at this. So you have a 1 less than 5 is okay, but a 4 bigger than the 5, so this is invalid binary tree. For this question, you have a different method to solve it. And today I'm going to use this way. First, we look up the tree structure, and normally we have a different kind of tree, like a DFS. Post order, the tree is bottom, top, left, bottom, left, top, right. 1, 2, 3, 4, 5. Here is the pre-ordered, is 1, 2, 3, 4, 5. And in today we're going to use this one. It will be, this is the one kind of tree we are looking for. 1, 2, 3, 4, 5. This is another type of tree. 1, 2, 3, 4, 5. I will write the code, then we walking through this one. We could write the code against this one. I will have a stack. So every time if the stack is not empty or the root is not empty, I push the stack in. But first in and then will be last out. So I then start popped out. Once I popped out, I compare, do I need a loop from a child? No. Then I just compare this with the in order. If this one smaller than the in order, means this is invalid. Otherwise, I'm going to the parent and compare this one and continue with the left and the right compare. So that is my idea. So let's just write the code. So I have a stack tree. So a new stack. I'm going to have the smallest one hold this the first node called define it as in order. So it will be the left. If you have the smallest one, you definitely won't have an integer we are smaller than this one. So I'm going to loop this one. I have a while loop. If this stack dot is input all and the root, because after I push everything, I push to in, then I pop up, compare, finish. I didn't find any in this. I will check it valid situation. If I didn't find any invalid, in this case, I'm going to return true. So what I'm going to do inside actually, I need to do a loop. So in first I come in, my stack definitely empty. I push one in. So I push one in, I push the root in. So once I push the root in, you see I push the 4 in, then my stack dot will push this root. Once I push the root in, I will traverse because that's in order supposed in here. So I traverse to the end of this tree. So this once this while loop for this case, it will be push 4 in, then push 2 in, then push 1 in. This loop is finished. In my stack have a 4, 2, 1. After finish, I will just pop up trying to find, because I don't have anything to compare, so I push to this little one. Then after I finish, I just get my root. Yeah, this is the new root. So I pop this one. In this case, it'll be 1. Yes. So and I'm going to see if this root dot value and smaller equal to in order. In this case, it definitely won't. No integer can smaller than negative double minimum value. But I'm going to replace this in order. In here, and now this is 1. After the first loop, first y in here, then the root equal to root dot right. So just let's walking through the code with this example, see if it is like what you expect, and they also help you to understand the code working. So first you see you have a stack equal to no. So input is stack, then you have this is, you definitely won't have an integer smaller than this one, so it eventually going to replace. So when first time come in and the stack is empty, yes, but the root actually is 4, so root is not empty. So while root not empty, I'm going to push the root to the stack. In this case, the root C is 4, so I push the stack, so we have a 4, and the root equal to root dot left is 2. Root dot left is 2. And then you compare root equal to no, not. Root push the root in, then the 2 push the in. After 2 push the in, 2 equal to root the left, then the root replaced by 1. Still root not now, so you continue past the in equal to this one, and then the root equal to root the left. This root to the left in this time is null. So first time this broken, you have this stacked in. Then you come in and update the root. You from pop in this time you will pop up 1 out here, and then remove the 1 pop up, put in the root. Then you compare root value smaller than equal to this one. No, definitely no integer can smaller than the smallest double minus value. And then you're going to update in order. So this time in order we are equal to root dot value. Root dot value is 1, so it actually is 1. So here finish. Then you're going to root equal to root dot right equal to root dot right. In this case, it's going to be null. And this finish, then you're going to here, the root is null, but the stack empty null. And then you compare the root equal to null, so you got this one null. And then you're going to pop up the lot. This time it will be 2. You pop it up, you remove from the stack. And once you say, did this satisfy 2 less and equal than 1? No. So it is going to next one in order. So in order going to replace by the root value. In this kind, then equal to 2. You are in the 2 equal to right. So in this time, root change to 3. Okay. Then you come finish this one. You come back. Is stack is empty? Is no. This also not satisfied. So it is continue coming in. Once you coming in, the root is not empty. Yes, it's 3. It's not empty. So you coming in, push the 3 in. And then the root equal to root dot left. 3 dot left is null. And this while loop finish, you pop up this one, then you pop the 3 up. And then you compare root dot value 3 less and equal than 2. No. So you change the order to and root the value. And then you change the root. Root is 3. 3 dot right is null. Now this time is null. Then you come back to here, and the stack is empty now. So you come here. The root is now, not now, no. So you go into here, root.stack.pop, root equal to 4, and you remove from the stack. And the root.value smaller, 4 small, no. So in order in equal to root.value, in order equal to root.value equal to 4. And this one finish, you change root equal to root.right. 4.right, it is 5. And once you finish, you come to here, stack is empty, but the root long, no. So you go into here, root stack, push the root, push the 5. Okay, then the root equal to root.left, this time is no. And then you the loop coming out from this loop, you loop from the stack, pop out the 5, and you move the. Now this time be now you push it to this one, and you see 5 less equal to the no. So you go in here, update this to 5. You go this loop, and then the loop equal to root.right, root 5.right, it is no. And then you come back to here. Okay, finish all of it. It is in order, you found it. So finish order didn't return false, you found it's correct. So in this scenario, you return true. Yeah, that is what I did for this one. This one solution, and let's submit the question. Haven't submitted. Suppose it accepted. Cannot find the simple stack the symbol, of course this is not a function. It accepted. And now finish this one, you actually have another way could achieve. So look up another way. It actually is like this. So when you actually test each node is a binary tree. So go into here, you actually pass the root, but you give the left and the right, it is no. So you will come in, you first test and is this valid? If this is valid, in this case situation, if it is no, tree is valid, so you go into the left and go into the right until you find the invalid situation. So in here you see you first come into the root, and when you come in, if the root is no, then you definitely return true. Otherwise you get the root the value, and you compare if the low and up not equal to no, so it won't be this situation. You definitely coming in and going to say put the right as the north node as the node. So as the node and the no integer, then you will become the current node, and the up node become what you passed in. So you compare this one. If this is invalid, you can then you just return false. Otherwise, you also, if this also not invalid and the right node is valid, then you can left is valid or not. If you get the left, and left is the node, but this time you first compare with the node, and the up nodes will be your value. So if this is invalid, then you won't. Otherwise, you will continue looping. The second time you will go into here, because the low and the up, you see low up not the value, you easy compare this or this. If not, and not any scenario found it, then you will go into return true. This is a binary tree way, so it's more easy and normally quite recursive and not very strong in recursive loop. So I more prefer like my previous solution. And thank you for watching. Hope you find that this is helpful. Thank you. Bye bye.